I'm Jake. Today I'm in the kitchen demonstrating the layers of the Earth. We will demonstrate the compositional layers of Earth with this avocado. First we have the skin, which is most like Earth's crust. It is the solid outermost layer of Earth. Then we have the middle, or the meat, of the avocado, which is most like Earth's mantle. It is the thickest layer of Earth. Finally, we have the pit, which is like Earth's core. It is dense, solid, and the innermost layer of Earth. Next, I will be representing the physical layers of Earth. This caramel will represent the thin lithosphere, the outer layer of Earth. The lithosphere is a solid composed of oxygen and silicon. It is at a temperature of whatever the air temperature is to 870 degrees Celsius. Next, I'll be using this red icing to represent the asthenosphere. The asthenosphere has a property known as plasticity. That means it is a flowing solid. Next, I'll be using this whipped cream to represent the mesosphere. The mesosphere is at a temperature of around 3,000 degrees Celsius and is composed of iron and magnesium. Next, I'll be using this chocolate ball to represent the inner core. The inner core is a dense solid that is at a temperature of 6,000 degrees Celsius. It is composed of iron and nickel. Finally, I'll use this molasses to represent the outer core. The outer core is a liquid that surrounds the inner core. It is also composed of iron and nickel. It has a varying temperature of 4,000 to 5,000 degrees Celsius. This is our finished model. Next, I will be explaining the theory of plate tectonics. Plate tectonics is a theory that the lithosphere is divided into blocks called tectonic plates. These blocks move on top of the lithosphere. To represent the lithosphere, I've taken these graham crackers and filled it with whipped cream. There are three types of tectonic plate boundaries. There are convergent boundaries that push into each other. There's divergent boundaries that move away from each other. And then there are transform boundaries which push side to side horizontally. There are three types of convergent boundaries. There are land-to-land collisions that push into each other, and because they are the same density, they push up and create mountains. Next, I will be showing land-to-ocean and ocean-to-ocean collisions. So, oceanic crust, is denser than continental crust. So, when they collide, one pushes down. So, our oceanic crust has gone below the continental crust, and these are known as subduction zones. You can find trenches and volcanoes at these boundaries. These are also like oceanic to oceanic crust collisions because one is always denser than the other and they push down. Next, we have divergent boundaries. Divergent boundaries pull apart because magma from below in the mantle squeezes out and pushes it apart. The whipped cream shows the magma from below pushing. When they diverge, they are mostly found at oceans, thus they form mid-ocean ridges. Next, and finally, we have transform boundaries. Transform boundaries move horizontally side to side, creating friction in the middle. The San Andreas Fault in California is a great example of this. It is a transform boundary, and it is the reason that there are so many earthquakes in California. Earthquakes are commonly found at transform boundaries. They move about the length, as well as all tectonic plates, that your fingernail grows in a year. Now I'll show a final representation of how Earth's continents were made. As you can see here, I have some heavy cream in the pan to represent Earth's mantle. To represent Earth's crust, I'm going to pour this cocoa powder in a thin layer over the cream. So now you can see water, the mantle, is boiling over, divergent boundaries forming here and here, and soon it's going to start creating continents. Yep, there's a divergent boundary forming right there. Field running. Sort of like how Pangea was separated into Gondwana and Laurasia. See the crack dividing the two. There's our single continent. I'd like to thank my mom, the Academy, YouTube, me, and as you can see, we have a little crack forming right there where it's starting to push up, as well as over here. Now we can wait and see when they form. What if Earth had turned out like that? Brett.